In this video, we're going to discuss about thread priorities in Java. So in this video, you're going to understand a lot of good and very important concepts in multi-threaded programming. And these are the concepts that are actually very useful in coding interviews, and they're oftenly asked in coding interviews because they expect that if a programmer has some knowledge about multi-threaded programming, then he actually knows how the threads are working with the CPU and the operating system. So what I'm going to do here is, instead of giving you some boring definitions of each and every terms, I'm going to I've created a very good example here. And what's good about this example is that this example is used, and it will be used in a lot of different areas of computer science. This same example is used in operating systems and in a lot of other subjects like operational research too. So let's start with the example, and after I will be able to explain you, or I will explain you this example. This is a real life example. Then what I will do is I will relate it to the terms in Java or in multi-threaded programming. Alright, so let's get started. So now, first of all, let's say we have a cinema hall. We have a cinema hall which has some seats available inside this hall, and let's say there are 100 seats available. So now there is a manager of the cinema hall, and this manager wants to fill the cinema hall and wants to fill these seats in the cinema hall. So what he does is he hires a person, and let's say that the name of the person is person A. So manager tells this person to build a logic and a system in a way that all the seats of the cinema hall can get occupied without causing any much problem, or you should say in efficient manner. So what this person does, he employs two more people. He builds up, or you should say he deploys two counters. Let's say these are the ticket counters. I'm going to write here ticket counters, and he employs two people in here. And now what will happen whenever the customers will come in these two counters? Now the customers will come and they will buy the ticket, and in that way they will be allowed to enter the cinema hall. Now let's say this person A, what he does is he is actually a ticket checker. So whenever any person has received a ticket, what this person is going to do, he's going to check whether the ticket is there or not. He will also check the identity of this of all the customers who are coming, and then only he will allow the customer to enter into the cinema hall. So now what he does is he says that he will open both of the ticket counters at the same time. So I'm going to write here that this is a situation 1. This is a situation 1, and it is a situation where two counters are running simultaneously. So both of these counters will run simultaneously, and this means that both of these counters will deliver the ticket to the customer, and at the same time the customer will go to the ticket checker. But suddenly this person A saw a problem in here. He says that I cannot check two person at the same instance, because this person A is not a multitasking person, let's say, and he says that I cannot actually check the tickets of two person at the same time. So he applies some logic, and in this logic he says that okay, what he will do is he says that I'm going to tell the person employed at this ticket counter to wait for, let's say, 2 seconds. So what will happen is, first the person at this ticket counter will deliver the ticket to this person, and as soon as he gets verified, at the same time this person is going to wait for 2 seconds, and for 2 seconds, then after the 2 seconds the customer will be able to enter this slot, and the ticket checker will check his ticket, and then he will get allowed in this in the cinema. Now let's study another situation, which is situation number 2. Same example. The cinema, there is a cinema hall, same cinema hall with same number of seats available, but now there is a different manager. So this different manager hires another person. Let's say this is a person B. So this manager also asks person B to find out some logic and a system in which he will be able to deliver the tickets to the people so that they can enter into the cinema hall. So what this person B does, he also creates 2 ticket counters, just like in the previous case. He will create 2 ticket counters, and similarly these will also have some customers here which are standing in a line, and this ticket counter will also have some people standing here in the line. Now this person B also experiences the same problem, but he says that instead of making this person who is assigned this counter to wait for 2 seconds, what I'm going to do here is I'm going to assign a higher priority to this person at this counter. A higher priority to this counter. Now why he is doing that? Now he will assign a lower priority to this one. Now why is he doing this? Why he is using a different approach? The reason is that if this person is here for 2 seconds, he will charge some money from the ticket checker. So this person B is really smart, I should say, and what he does, he says that okay, the first ticket counter will give the tickets to all the customers standing in this line, and after this whole ticket counter will be done selling the tickets, then this ticket counter will come and into play, and the person will come to this ticket counter, and then he will work. So what is happening is this is actually another situation too, where these 2 counters are not working simultaneously. So not working simultaneously. So these are the 2 situations, and this is the example. Now let's relate it with multi-threaded programming in Java. Now you see this person here, which is the manager, is actually the operating system. He is the operating system, and this operating system hires this person, and let's say that this person is a thread scheduler. Now different operating systems they employ different strategies to do the multitasking processing. So I'm going to write here multitasking. So in order to achieve multitasking, there are different operating systems. So if you consider Java programming language, we know that Java is a platform independent programming language. But a platform independent does not mean that it can actually change the architecture of any operating system. It will have to work according to the operating system to achieve multitasking. It cannot change the architecture in any way. So now these persons are actually thread scheduler. B is also a thread scheduler. So let's understand what is a thread scheduler. A thread scheduler assigns priority to a thread. Priority to a thread. Now here you can see these 2 people in these 2 counters. In both the situations, these people are actually threads. They are actually threads. So what the thread scheduler does, he assigns a priority to a thread. in the first case, since both of these were running at the same time, so both were assigned a same priority. So I'm going to write here, in situation 1, both the threads have same priority. So a priority is actually has a range from 1 to 10. 10 means a maximum priority and 1 is the minimum priority or the lowest priority, and 5 is actually a normal priority. So let's suppose in this case, in the situation 1, where the two threads were running at the same time, what the thread scheduler will do, it will assign both these threads the same priority. So in order to see what is the priority of a thread, we can actually use a getPriority function, and we will call this function on the instance of the thread class. So let's suppose I want to see what is the priority of the thread 1. Let's suppose this first counter is T1 and the second counter is T2. So we can actually call the getPriority function here. Now this T2 thread is actually waiting for 2 seconds, and by the time it waits for 2 seconds, this thread 1 will actually be able to process. So this is similar to a program where we have two threads, one is T1 and one is T2. T1 is working whereas T2 will sleep. We are going to use the sleep function, and to wait for 2 seconds we are going to specify 2000. So we can actually wait or sleep a thread to do the multitasking. Now you can see we can another way to let this thread wait is to get some user input, so that at the time when this thread is actually taking some input, let's say some cash from these guys or some ID, at that time the ticket counter 1 will be able to send a person to the ticket checker. So now let's see the situation number 2, where where this thread scheduler is not assigning the priorities as same to them. And what we can do is, as a programmer, we can actually control this. If you will not specify the priority of a thread, the thread scheduler will automatically set it to some default priority. But if we want to act like this, act like person B, what we can do is we can use a dot. I'm going to write here situation 2. For situation 2, we are going to use a setPriority function. P is capital here, and let's say this is thread 1 and this one is thread 2. So let's say we want to assign a higher priority to this thread, so we can actually do it using this function, and we are going to specify 10 here. If you don't remember these numbers, you can actually use a keyword which is the max underscore priority, like this. Now if you want to assign T2 a lower priority, what you are going to do is you are going to write T2 dot set priority, and you are going to assign 1, or you can use the keyword min priority. And in case you want to actually assign the default priority, you can use the keyword norm, which is the normal priority. So now you can see here, in this situation 1, we have two threads running simultaneously and one thread is waiting for 2 seconds. And in this one, the higher priority thread is running first it will execute, and then the lower priority thread will execute. Now I explained you that in this situation number 2, this higher priority thread will run first, and this means that this person is going to come into the ticket counter only after this thread will finish its execution. This means that this thread will take the counter. We have assumed that the ticket counter is actually a CPU. So the thread will enter into a CPU only when only when the higher priority thread has completed its execution. So now you can see that after this it will enter CPU time. Now in theory, a higher priority thread takes higher CPU time than a lower priority thread. So if you can even see this from this example, it's clear already that a higher priority thread will take a lot more CPU time than the lower priority thread. Now I'm going to explain you a very important concept now, which is in both of these situations there is a limitation. So let's say there is a person C who is a much experienced person and he has already seen these two situations. Now what he says is, what his idea is, he says that in situation 1, if you will implement the situation 1, you're actually consuming too much of CPU, and let's say the manager does not have that much money, or let's say the manager does not have that much money to employ two employees, 2 ticket counter cashiers. So in that case this will have a limitation and will be a waste of money, and money in this case it will be the CPU time. And here in this case what we can do is, first this thread will execute, and then this person can only come here and he will try to execute this. So here the limitation is the higher CPU time, because both of the threads are running at the same time, they are allocating the CPU. Here there is a limitation, and if you have observed this limitation, it's really good. And the limitation is that, for example, this higher priority, this one is running, and only after this will execute and finish its execution, then only this lower priority thread will be able to run. And this will cause a problem in case when we have a lot of customers in the first ticket counter. So let's suppose there are thousands, or let's say there are so many customers, and it will take a lot of time for this thread to complete the execution. And in some cases it is observed that this thread will never get a chance to run. So this means that this thread will never be able to, I'm going to write here a very important term, relinquish control. So this thread will become almost a dead thread, because it will not be able to relinquish the control over the situation, because the higher priority thread is taking so much time to execute, to just execute its operation. In that case, this person C has analyzed both the situation, and he says, what if we do something like this? What if we say that the higher priority thread will run, but after some time, after let's say some time, we are going to wait for some time, let's say 5 seconds, and this higher priority thread will wait for 5 seconds, and at that time we are going to give or relinquish control to the lower priority thread. And meanwhile this thread will wait for 5 seconds, which means that this person will leave the CPU for 5 seconds, or the ticket counter for 5 seconds, and he will come here and he will start giving tickets to these people. Now what will happen is, after 5 seconds this queue has again a higher priority thread. Now since this has a higher priority thread, now this person will have to move again back to here. Now this movement is actually known as preemption. This is also again a very important term, preempt. Preempt means that you are actually stopping, or you are leaving a particular thread and you are going into another. So I'm going to write here a very important line here, which says that a higher priority thread can relinquish control over lower priority thread. And I hope this makes sense from this example. You can see that if we will assign higher priority, we can just wait for 5 seconds, and for that 5 seconds we are giving lower priority a chance to just get the control and starts its execution, or to start giving the tickets in this example. So after some time the thread priority will again become alive, and then this thread will have to relinquish control, and the higher priority thread will stop or preempt the lower priority thread to start its execution. So we have understood, this example is really useful, and it will be used a lot in the future to explain multitasking. And if you will give this example to the interviewer, it will be really good, and it's also good for retention power also. You will always remember this, all these concepts using this simple example. So what we have studied is, we now know the working of thread scheduler. We know that different operating systems has different ways to handle multitasking, and we have two situations in which in the first situation both the threads are running simultaneously, and in this one we are actually assigning a priority, and this smart person C is making a combination of both of them, and he is actually making this higher priority thread wait for some time, and in that way it will be this lower priority thread will be able to execute the code. So this is actually a good programming or multi-threaded programming strategy, that you will assign a higher priority thread and a lower priority thread, and at the same time you also create a code which will wait for some time if you're assigning a higher priority thread. You can even use some by taking some user input, and at that time the control will go to the lower priority thread. So these are the very important concepts, and it was related to multi-threaded programming. In the next tutorial we are going to study a very important concept, again a very important concept, which is known as synchronization. We're going to study this topic, synchronization, and we will also be able to implement this in Java. So that's all for this tutorial. Thanks for watching.